Alright, next concept is evaluation of integral over a given region in Cartesian coordinate system. Right, here in this case sometimes we are given in the region in not in terms of x and y coordinate systems or x and y coordinates, but in terms of a curve or area bounded by the curves. To evaluate such integration, we have to first of all draw them, understand the curve, draw them, and then find their limits and putting those limits and then solving it. Right, so this much part is needed. So let us see first example number 1. Evaluate double integration of y dx dy over the area bounded by x is equal to 0, y is equal to x square, x plus y is equal to 2 in the first quadrant. This is the question. We have to evaluate this integration over the area bounded by x is equal to 0, y is equal to x square, x plus y equal to 2 in the first quadrant. Let us first of all understand these curves and draw them. Right, if this is my coordinate system, xy coordinate system, xy axis, right, x is equal to 0 is y axis. On y axis x is always 0, so x is equal to 0. Next is y is equal to x square. Now y is equal to x square is a vertical parabola, so it will be somewhat like this. Y is equal to x square. Right, next is x plus y equal to 2. It's a line, right, but you need to understand what are there, what you can say 2 points. We need 2 points to join this line. So when x is equal to 0, y will be 2. So first point is 0 comma 2. When y is equal to 0, x will be 2. So 2 comma 0. Right, so 0 comma 2 and 2 comma 0 comma 2. That means somewhere here 0 comma 2 somewhere यहाँ पे this 1 2 and 2 comma 0 1 2, somewhat like this. Right, this line will go like this. Right, but we need to find these 2 points. What they have asked to find the area bounded by these 3 curves in the first quadrant. That means we are not interested in this part, we are interested only in this part. That means this line, this parabola, and this line, this x is equal to 0 line, out of these 3 curves, इन तीनों ने जो area bound किया हुआ है, let's say which one will be bounded by these 3 curves? Obviously this one, this region, not this, not this, not this. ये तो है ही नहीं, because we are interested in first quadrant only. So this will be the region where we need to find this integration. Right, so for that, if I expand this will be somewhat like this. Right, can you see it? This is the region. Right, we need this value and these are the intersecting point. Obviously this is 0 comma 0. What about this and this? This is what we need, we are interested. This line is x plus y equal to 2. If I want to find the intersecting point of this parabola and line, I'll compare x plus y is equal to 2 and y is equal to x square. If I put y is equal to x square here, then this become x plus x square equal to 2. If I take out x common, 1 plus x equal to now we'll put this y is equal to x square in this. We have to find the intersecting point of this curve parabola and this line, right? So there are 2 curves, x plus y equal to 2, this line and I hope you can see. Y is equal to x square. This is the parabola, right? Now either you put this value in this equation or this in this. This is much more convenient to put y is equal to x square in this equation. So this become x plus y is equal to x square. So putting this equal to 2. This is x square plus x minus 2. Just shifting this 2 on the left hand side. Now this is a quadratic equation, right? So putting the values माइनस, अब देखते हैं माइनस टू एक्स स्क्वायर के ऐसे कोई फैक्टर्स है जिनका एडिशन 1 हो, माइनस टू एक्स स्क्वायर और माइनस 2 के जिनका एडिशन 1 हो, 2 माइनस 1 हो सकता है, 2 1 2 माइनस 2 एंड दिस इज 1, राइट? दिस इज एक्स स्क्वायर प्लस 2x माइनस एक्स माइनस 2 इक्वल टू 0. सो x इंटू एक्स प्लस 2 into minus 1 x plus 2 equal to 0 common. So first bracket x minus 1, second bracket x plus 2 equal to 0. Therefore we have two values of x is equal to 1 and x is equal to minus 2. Now for these two values we need to find the value of y. Now इसकी वैल्यू यहाँ पुट करके आपने आंसर किया है, अब ये वैल्यू आप यहाँ पे पुट करेंगे. So when x is equal to 1, y will be 1 square, that is 1. So first intersecting point is 1 1. Obviously 1 1 will be here, right? Then when x is equal to minus 2, y will be minus 2 square, that is 4. So second intersecting point is minus 2 comma 4. Obviously this is this point, minus 2 comma 4, right? All right, next thing. Now for finding the integration of this region, we have to either take the strip parallel to x-axis or y-axis. Now it is always depend on you which strip or which strip you want to take, whether it is parallel to x-axis or parallel to y-axis. Why? Because if you, now I'll just give you example. If I take the strip, this is the region. If I take the strip parallel to x-axis, let's say this one. If you can't imagine, this is the region, right? If I take a strip parallel to x-axis, I need to move this strip from this point to this point. But while doing this, now it may be noted that the property of one important property of this strip is that it can travel only on two curves, only on two curves. The moment the third curve involves, we have to divide this region. If I shift this strip from downward sides to upward sides, till now it will be moving on these two curves. This is x is equal to 0 and this is y is equal to x square. इन दोनों पे वो मूव कर रही थी, right? The moment it reaches this point, it shifts from y is equal to x square to this region. This is x plus y equal to 2. This is a line, right? So अगर हम लोग, if we take a strip parallel to x axis, then we have to divide this region into two sub regions. Why? Because strip can only travel on two what you can say curves, right? And therefore in this case, if I take a strip parallel to y axis, then from this point to this point, it is only moving on these two curves. This curve is y is equal to x square, this curve is x plus y equal to 2. So it is much more convenient to take a strip parallel to y axis rather than taking a strip parallel to x axis, because if you take strip parallel to x axis, then you have to divide this region into two sub regions, because this point where this strip travels more than two curves, therefore it will be better to take a strip parallel to x axis, y axis, right? And therefore I'll just show you here, I am taking a strip parallel to y axis. Now strip is from this curve to this curve, so this will be the limit of y. Now next part is after understanding the curve, then finding their intersecting point, then deciding whether which you want to take a strip parallel to x or y axis. Afterwards, next step is you have to write the limits. Now if you have taken the strip parallel to y-axis, then you have to write limit of y in terms of x, because this strip parallel to y-axis, so it is moving on these two curves, right? From downward size to upward size, this y varies from this curve y is equal to x square to this curve. This is x plus y equal to 2. Can I write x plus y equal to 2 as y is equal to 2 minus x? Can I write this x plus y equal to 2 as y is equal to 2 minus x, just shifting this x on the right hand side, and therefore the second limit of y will be 2 minus x. Since the strip is parallel to y-axis, so you have to take the limit of y in terms of a curve y is equal to x square to y is equal to x 2 minus x. On the other hand, x will vary from this point to this point. Now here we already know that x coordinate is 0, right? So x will vary from 0 to x is equal to what? 1. So x is equal to 1 will be your limit. So these are very important for solving any examples wherein you have been given by a curve or area bounded by some curves, right? So first of all, draw them, find the intersecting point, then decide which strip you want to take, whether it's parallel to x-axis or y-axis, and then find it. This is also correct, but this will give you this will consume your time. Therefore we have taken a strip parallel to y-axis, right? And now this integration I becomes, these are the constant limits, so you have to write them outer or the first limit. That means you have to integrate by this variable lastly, right? Then second, these are the limit of y, so y varies from x square to y is equal to 2 minus x. Then these are the limit of y, so y, now here this is dx first written and then dy, but since you found that these are the limit of y and they are in terms of x, so you have to integrate with respect to y first. So you will first of all write, interchange this, first of all write with respect to dy with respect to y and then dx. And now this question transforms to your earlier topic, that is finding the integration by simple limits when limits are directly given. It's very easy. What is the limit? Integration as it is, 0 to 1 as it is. What is integration y? Y square by 2 from x square to 2 minus x into dx, right? Now next thing, don't consider this region. I am using or saving papers, whatever you call it. So this will be continuing this. I equal to integration 0 to 1 upon 2, you can take out common, then y square x square to 2 minus x into dx, right? Now simplifying this, we have one upon 2 as it is, 0 to 1 as it is. Put the upper limit, lower limit. Now y square, instead of y square I have to write 2 minus x, but its square is given, so 2 minus x whole square, minus x square instead of y, but y square is given, so x square into dx. Now expand this bracket, simplify, and then find the integration 0 to 1 as it is. What is expansion of this? 4 minus 4x plus x square minus x square raised to square is x raised to 4 into dx. Again simplify this. This is 1 upon 2 integration 0 to 1 Now you can directly take the integration. What is integration of 4? 4x minus, what is integration of 4x? 4x square by 2, integration of x square, x cube by 3 minus x raised to 5 by 5, and put the limit, upper limit 0 to 1, right? Simplify this. This will be 1 upon 2 inside the bracket 4x minus 2 ones are 2 twos are, so this is 2x square plus x cube by 3 minus x raised to 5 by 5. Put the upper limit, lower limit. Now as I already told you, when there are the limits are in terms of 0 and 1, the constant sum will remain only. So this will be 1 upon 2. I can directly write 4 minus 2 plus 1 by 3 minus 1 by 5. You can put the values and check it. Now this will be 15 is their LCM, so this is 1 upon 2, 15, so this will be, can I use this 4 minus 2 as 2, so this is 2 plus 1 by 3 minus 1 by 5. Again simplify this, 1 upon 2 as it is. This will be 15, so 30, 15 2s are 30 plus 1 plus 5, LCM is 15, so multiply divide by 5, and here multiply and divide by 3, so this is minus 3 divided by 15. Simplify this. This will be 1 upon 2, 30 plus 2 divided by 15, so this will be 32 divided by 15 into 1 upon 2, so the answer is 16 by 15. Alright, next example. Next example is example number 2. Evaluate double integration over the region R of the function e raised to 2x minus 3y into dx into dy over the triangle bounded by x plus y equal to 1, x is equal to 1, y is equal to 1. This was asked in 2013 examination. Now again here there are three regions given, and we need to find the integration of this function over or area or region bounded by these three curves. Let's first of all draw them first. This is xy coordinate system. X, y. X plus y equal to 1. Right? Let us first of all write x is equal to 1 is what? If this is x is equal to 1, then x is equal to 1 will be a line parallel to y axis. Let's say this is x is equal to 1. Next, y is equal to 1. This is x is equal to 1, then this will be y is equal to 1. Right? Next is x plus y equal to 1. If x is equal to 0, then y is equal to 1. If I put x is equal to 0 in this equation, then y is equal to 1. So your first value is 0 comma 1. 0 comma 1 will be somewhere here. Right? 0 comma 1. Then if I write y is equal to 0, then my value of x will be 1. So next point is 1 comma 0. 1 comma 0 is here, and therefore this line, can you see it? This line will pass from these 2 points like this. And now we have to see which region is bounded by these 3 curves. Right? First of all, this is x is equal to 1, then y is equal to 1, and then this line. So obviously, which will be the region bounded by these 3 curves? This or this? This will be the region, right? This is x plus y equal to 1, this is x is equal to 1 and y is equal to 1, and now we have to find the double integration of this region of the function over this region. Right? Now again here there are 2 possibilities, either you take a strip parallel to y axis or x axis. दोनों भी, both are applicable, because here if you take a strip parallel to y axis, then also it is traveling on these two curves, and if you take a strip parallel to x axis, this will carry and this will travel on these two curves. So दोनों भी चल सकता है. पहले इसमें हमने विद रिस्पेक्ट y एक्सिस को पैरेलल लिया था. सो लेट अस टेक अ स्ट्रिप पैरेलल टू x axis now. Now if you take a strip parallel to x axis, then your limit of x will be in terms of curves, right? X will vary from this curve to this curve, and at the same time y will vary from this point to this point. So next is limits. लिमिट्स क्या होंगे? x के लिमिट सबसे पहले, x वैरीज फ्रॉम दिस पार्ट. यहाँ पे x की वैल्यू कितनी होगी? इफ आई माई इक्वेशन इज, कैन यू सी इट? इफ माई इक्वेशन इज x प्लस वाई इक्वल टू 1, अगर मुझे यहाँ से x की वैल्यू चाहिए तो दिस इज x इज इक्वल टू 1 माइनस वाई, एंड देयर फॉर माई फर्स्ट लिमिट ऑफ x विल बी 1 माइनस वाई टू x इज इक्वल टू 1. This is the limit of x. At the same time, y will travel from this point to this point. Here, at this point, y value is 0, and at this point, y value is, can you guess? Can you guess this point? This is 1, 1. Because यहाँ पे 1 है, यहाँ पे 1 है. Y will vary from y is equal to 0 to y is equal to 1. So these are the limits. And therefore, using this limit, your function or question becomes, these are the constants. So you have to write them outside. Y is equal to 0 to y is equal to 1. Then next integration, x is equal to 1 minus y to x is equal to 1. Then e raised to 2x minus 3y into dx first, because these are the limit of x, and then dy. This is your question now. And now here onwards it is very easy to solve this question. क्या होगा? This will be integration 0 to 1 as it is. Then here you have to integrate with respect to x only. So can I separate this part? This, can you see it? This e raised to 2x minus 3y, can I write this as e raised to 2x into e raised to minus 3y? When you are integrating with respect to x, this function or this e raised to minus 3y is a constant. So can I take it outside and just take the integration of e raised to 2x? What is integration e raised to 2x? I'll write down 1 minus y to 1 e raised to 2x into dx, and then the limit dy, right? Simplify this 0 to 1 as it is, e raised to minus 3y as it is. What is integration e raised to 2x? E raised to 2x divided by 2 from 1 minus y to 1, and dy still waiting, right? Next thing is integration as it is. This 1 upon 2 I can take outside, e raised to minus 3y as it is. Now put the value or put the upper limit at x. So e raised to 2 into 1 minus e raised to 2 into lower limit is 1 minus y into dy as it is. Again simplify this 1 upon 2 as it is, 0 to 1 as it is, e raised to minus 3y as it is. Inside this is e raised to 2 minus e raised to 2 minus 2y. All of you getting this? Right? Now multiply this e raised to minus 3y into the bracket. So this is 1 upon 2 integration 0 to 1. E raised to minus 3y into e raised to 2 is e raised to 2 into e raised to minus 3y, minus this again I can separate as similar to this. This is e raised to 2 into e raised to minus 2y. So can I write this as e raised to 2 into e raised to minus 3y into e raised to minus 2y will become e raised to minus, in the law of indices, minus 3 minus 2 is minus 5y, and then the integration with respect to y. Now as you can see, e raised to 2 and e raised to 2 is a constant. So taken outside this integration, this is e raised to 2 by 2 integration 0 to 1 e raised to minus 3y minus e raised to minus 5y into dy. Simplify this. Inside this integration, what is integration e raised to minus 3y with respect to y? it is e raised to minus 3y divided by minus 3. Minus sign, e raised to minus 5y divided by minus 5. These are the integration of e raised to minus 3y and e raised to minus 5y with respect to y. Now simplify this. Put the upper limit and lower limit for both these variables. Minus 3 as it is, e raised to minus 3 into y upper limit is 1, minus e raised to minus 3 into 0. This is the upper limit and lower limit of first function. Minus minus becomes plus. So can I write this as plus 5 e raised to minus 5 into 1 minus e raised to minus 5 into 0. Right? Simplify this. This will be e raised to 2 minus 2 divided by 2 minus. Now again this is e raised to minus 3 minus e raised to 0 divided by minus 3 plus e raised to minus 5 minus e raised to 0 divided by 5. Simplify this now. This will be e raised to 2 by 2. Inside this is e raised to minus 3. Can I write over here? E raised to 2 divided by 2. Inside it is e raised to minus 3 by minus 3 minus of e raised to 0, that is 1, minus 1 upon minus 3. Can I write this as 1 upon 3 plus 1 upon 3 plus e raised to minus 5 divided by 5 minus 1 upon 5. Is it right? Simplify this now. Is it right? Next thing is simplify this. This is e raised to 2 by 2. Inside this is, can I multiply this by this bracket by e raised to 2 by 2 inside this bracket? This is what? This is minus 6 in the denominator. E raised to 2 into e raised to minus 3. Law of indices, the base will be same. Addition 2 minus 3 is minus 1. Right? Then plus. Now you have to first of all simplify these two. This is what? This is 1 by 3 minus 1 upon 5. This will be 5 minus 3 divided by 15. So this is 2 upon 15. So 2 upon 15 into this bracket, that will be 2 get cancelled. So e square by 2 upon 15 so this will be 2 get cancelled. So e square by 15 will be your answer, right, for this simplification and this multiplication. And then the last one plus 5 into 2 is 10. E raised to 2, e raised to minus 5 will be e raised to minus 3, right? And therefore your simplification or simplified answer will be, final answer is e raised to minus 3 by 10 minus e raised to minus 1 by 6 plus e square by 15. This will be your final answer. I hope it is clear, right? Alright, this is example number 2. Alright, next question is example number how much? 3rd. Evaluate double integration over the region R. Can you see it? Evaluate double integration over R of the function x square into dA, where R is the region, and R is the region in the first quadrant, bounded by the hyperbola xy equal to 16 and the lines y is equal to x, y is equal to 0 and x is equal to 8. This was asked in 2014 examination. Now this is very interesting example. Let us first of all draw these areas. Y is equal to x square. First of all we'll draw these three curves. This is your xy coordinate system. Y is equal to x obviously is a line passing through the origin making an angle 45, right? Y is equal to x. Let's say y is equal to x. Next is y is equal to 0. Y is equal to 0 is this line, that is x axis, and x is equal to 8. If I say this is my 8, 1 2 3 4 5 6 7 8, then this will be somewhat like this, x is equal to 8, right? So obviously this point will be 8 comma 0, is it? Y is equal to x, y is equal to 0, this is y is equal to 0 and x is equal to 8. Next is xy is equal to 16. If you xy is equal to 16, if you simplify this and then find and draw it will be somewhat like this. This is a parabola in the first quadrant, so hyperbola. So this will be somewhat like this. Hyperbola, right? This is xy equal to 16, right? Now if we draw this separately, then this is somewhat like this type of region, right? We have to find these points or these intersecting points. This already shown you that this is 8 comma 0, this will be the point 0 comma 0, right? These are the two intersecting points. We need to find it. The intersecting point of y is equal to x and xy is equal to 16. For that we need to y is equal to x. So put this value over here. So this will be x square. If I put y is equal to x, that means x into x, that is x square equal to 16. This means either x is equal to plus or minus 4. So now put this value in this equation. So if x is 4, y is 4. If x is minus 4, y is also minus 4. But since you are interested in only in the first quadrant, so you have to consider this point only, and therefore this point of the hyperbola and y is equal to x is 4 comma 4. Next part is you have to find this point. You already know that this is x is equal to 8, so x coordinate is 8. You have to find the y coordinate. This line is x is equal to 8, right? And this hyperbola is xy is equal to 16. So again, and xy equal to 16 and x is equal to 8. You have to put x is equal to 8 in here. This is 8y is equal to 16. This implies y is how much? 2, and therefore this point will be 8 comma 2. I hope it is clear to you, right? So 8 comma 2. Let us name it as O A. This is A point, 8 comma 0, then B, and this is C point, right? Now before proceeding with the limits, first of all see that if you take a strip parallel to y-axis, parallel to x-axis, then you need to take a strip parallel to x-axis. As we already know that the strip will travel only on two curves. The moment we reach this point, first of all it was traveling from this curve. This is y is equal to x and this is x is equal to a. The moment it reaches here, it will shift from x is equal to 8 to this curve, that is xy is equal to 16, and therefore we have to divide this region into two sub-regions and take strips, individual strips for different regions, right? Similarly, if we take a strip parallel to y-axis, let's say this is my strip parallel to y-axis. If I shift this strip, it is traveling from on this curve and this curve. This is y is equal to x, this is y is equal to 0. The moment it reaches this point, it shifts from y is equal to x to xy equal to 16 and y is equal to 0. Therefore, in both the cases, we have to divide this region into two sub-regions, take the individual strips and then find their limits, individual limits, and then solve it and then add the final answer, right? So in both the cases, you have to divide this region into two sub-regions. You can do as a homework, find the limit of this curve and then solve it. We'll consider this one, right? So the rectangular, therefore let us say this point is D. Again, I need to find the what you can say coordinates of this D point. As you can see, this is a line parallel perpendicular on this this is 4, so x coordinate is 4. But for y coordinate, if you observe, this is x axis, so on y coordinate x is 0, so the point is 4, 0. Can you see it? Yes, 4, 0, right? And therefore we have to split this region into two regions. ODC, split the region into two regions, namely ODC and DABC. Let us consider one by one. For ODC first, I need to find the limits now for ODC. Coming to ODC, this is the triangle. If you want, I can draw it. This is the triangle, right? And you are taking a strip parallel to y-axis. This is y is equal to 0. This line is x is equal to 4, right? This line is y is equal to x. Now, as you can see, we have taken a strip parallel to y-axis, and therefore the limit of y will be these curves. So y varies from y is equal to 0 to y is equal to x. At the same time, x will vary from, this is 4, 0, this is 0, 0. So you tell me what are the values of x coordinate. X varies from 0 to 4. X is equal to 4, right? Similarly, for DABC, again DABC is the region like this. I'll just draw it. As you already aware, this is the region, right? Roughly, we have taken a strip parallel to y-axis. This is x is equal to 4. This point is 4, 0. This is DABC. This is ODC, right? So DABC, this point is 8, 2. This point is 8, 0. This point is 4, 4. Strip parallel to y-axis. Therefore, the limits of y will be in terms of these two curves. This here, y will vary from 0 to y is equal to, this curve is xy equal to 16, xy equal to 16, and I need the value of y, so I'll shift this x on this side. Can you see it? So y will be 16 upon y. I'm sorry, 16 upon x, right? And therefore y will vary from 0 to 16 upon x. At the same time, x will vary from this point to this point. Here it is 4, here it is 8. Therefore x will vary from 4 to x is equal to 8. And therefore the total answer for the region R is OA, ODABC is nothing but region R is equal to x square into dA is equal to, first of all, the region for ODC of x square dy dx plus double integration DABC of x square dy dx. Simplify this now. Now here these are the limits. So here x is equal to 0 and x is equal to 4 are constant. So x is equal to 0 to 4. This is first. Then y is equal to 0 to y is equal to x. These are the limit of y. So x square is a constant. So you can take this outside, right, into dy and then dx plus integration DABC. Here the limit of x are constant. So x is equal to 4 to x is equal to 8. Then limit of y are y is equal to 0 to 16 upon x. Again x square is a constant, so taken outside into dy into dx, right? Next thing, 7, page number 8. Continuing this, integration over region x square into dA will be integration this 0 to 4 as it is, x square as it is. What is integration of dy? Integration of dy will be y from 0 to x into dx waiting plus 4 to 8 as it is, x square as it is. Integration of dy is y from 0 to 16 upon x into dx. Simplify this. Integration from 0 to 4 x square as it is. Integration of upper limit and lower limit now. This is x minus 0 into dx plus integration 4 to 8 x square as it is, 16 upon x minus 0. Right, 16 upon x minus 0 into dx. Simplify this now. This is 0 to 4 as it is, multiply by x. This is x cube into dx plus 4 to 8. X and x get cancelled, so this is 16x into dx, right? Again simplify this. This will be, what is integration of x cube? X raised to 4 by 4 from 0 to 4 plus 16 as it is. X integration of x is x square by 2 from 4 to 8. Simplify this. This is what? 4 as it is, 4 raised to 4 minus 0 plus 2 1s are 2 8s are. So this is what? 8 into 8 square minus 4 square. Simplify this. 1 4 get cancelled, so this is 4 cube plus 8 into, this is 64 minus 16. 64 minus 16, how much? This is 8 and this will be 4, 48, I guess 48. So 48. Simplify this. This is 4 cube is 64 plus 8 into 48. Total answer must be 448. Right? You can multiply by 8. Simplify this. This is 64, 6, 38, 384 plus 64. This is 8. This is 14, 1, 448. So the final answer is 448. Right? Next question, example number 4. Evaluate. See, whatever the question, main thing is you need to understand the curves, draw them, find the common region, the region bounded by these 3 curves or 4 curves, and then find their limits. If you find the limits, then the next part is very much easy. Solving the integration you have already studied, so no problem with solving any double integration. Next question is evaluate double integration xy dx dy over the region capital R given by x square plus y square minus 2x equal to 0. Next is y square equal to 2x, and the last is y is equal to x. Right? First of all, y is equal to x will be a line, obviously. Right? Y square equal to 2x will be a parabola. We have to understand what is this. It is not given, it is not mentioned here. Let us first of all understand this x square plus y square minus 2x equal to 0. Can I write this as x square minus 2x in one bracket, other bracket y square equal to 0? Instead of this, can I write x minus 1 whole square? What is x minus 1 whole square? X square minus 2x plus 1. The starting two terms are in this bracket. One extra term added. So for balancing this, I'll write down y square. Can I write minus 1? For balancing this, minus 1. X square minus 2x plus 1 minus 1, adding and subtracting 1. If we cancel this, only these two terms remaining. Again simplify this. Can I write y square as y minus 0 whole square and shift this one on the right hand side and write this as 1 square? What is the name of this curve or this equation? Circle with center at 1, 0 and radius again 1. Let us draw them now. This will be your xy coordinate system. We have to draw this somewhat in large size because next is circle with center at 1, 0. 1, 0 will be here. Let us say 1, 0. So circle will be somewhere like somewhat like this. As you already aware about my drawing skill, so please understand it. This is the circle, right? This is the circle, and then next is y is equal to x. Y is equal to x will be a line passing through the origin and making an angle 45 degree, right? Y is equal to x. This curve is x minus 1 whole square plus y square equal to 1, right? Next is a parabola. Now this parabola y square is equal to 2x will be somewhat like this. I have to extend this like this, right? And therefore the region of integration is bounded by these three curves. First of all, this line, then this circle and this parabola. So the region will be this one, this, then this, and the last one, this one. If I draw this separately, this will be somewhat like this, like this. Alright, now again you can take either strip parallel to y-axis or x-axis. As you can see that you have to divide this region into two sub-regions irrespective of the strip parallel to x-axis or y-axis. If you take a strip parallel to x-axis, then this will be a one strip and second strip will be here. On the other hand, if you take a strip parallel to y-axis, then first strip will be here and second strip will be here. We'll take this one. You can use this as well, right? So I'll separate these or divide this region into two sub-regions. First region is this one, second region is this one. For different region we need different limits. First of all, let us rename this as O, A, B and C. Now we need their intersecting points, right? This one, this point, this, and obviously this is origin, right? Origin hai 0 0. First of all, this line y is equal to x and this parabola, continuing this, page number 9. First of all, consider y square equal to 2x and this line y is equal to x. Now you put this value over here or this value over here. This is much more easy. Put this value here. So this will be x square equal to, instead of y I'll write x. So x square equal to 2x. This implies x square minus 2x equal to 0. Again take x common, so this is x minus 2 equal to 0. Either x is equal to 0 or x minus 2 equal to 0. That is either x is equal to 0 or x is equal to 2, or, right? Now this value you have put in this equation. Now this value you will put over here. Since y is equal to x, this implies that when x is equal to 0, y is also 0. So your first point will be 0, 0. When x is equal to 2, second point y will be 2, and therefore second is 2, 2. So the line, which line? This line and this parabola intersect at 2 points, 0, 0, and this is 2, 2. Getting this? Now next thing you need these intersecting points, right? So here this circle and this line, how to find this? Now for this intersecting point, what we'll do? For this intersecting point, consider this is circle and line. So consider x square plus y square minus 2x equal to 0 and y is equal to x. Which one is easy? Putting this value in this equation or this value in this equation? I think second one in first. So wherever you find y, put x instead of y. So this will be x square plus x square minus 2x equal to 0. Simplify this. This is 2x square minus 2x equal to 0. Take 2x common, so inside this is x minus 1 equal to 0. So either 2x is equal to 0 or x minus 1 equal to 0. This implies either x is equal to 0 or x is equal to 1. So x is equal to 0 and x is equal to 1. These are the points. Second point we need to find. So you have put this value over here and found this value. Now put this value in this equation. So when x 0, as y is equal to x, so y is also 0. When x is equal to 1, y will be 1, and therefore this second point is 1, this is 0, 0, right? Now as you can see, this is value of y, this line is parallel to y-axis. So if x is 1, this line, on this line x will be always 1. So here this is also 1. We have to find the second part only, second point only. Now when x is equal to 1, on the curve y square equal to 2x, this implies y square equal to 2. This implies y is plus minus root 2. So y is plus minus root 2. As we can see, this is in first quadrant, so this will be plus 1 comma root 2, right? And therefore these are the intersecting point. This is 0, 0, this is 1, 1, 1 comma root 2, 2, 2, right? Now this total region is divided into two parts. First one is we split, I'm sorry if you can't see it, we split the region in two sub-regions, namely OAB and ABC. OAB, A, B and C, right? C के values है 2 2, right? And therefore now limits, what are the limit? If you are taken strip parallel to y-axis, limit of OAB, limit of y will be this curve to this curve. This is curve for strip parallel to y-axis, so y के लिमिट होंगे this curve से this curve तक. अब यहाँ पे y के लिमिट कितने होंगे? This curve is also written as x square plus y square minus 2x equal to 0, right? So y square will be 2x minus x square. This implies what is the value of y? Y is under root 2x minus x square, and therefore limit of y will vary from root 2x minus x square to this one, this curve, or now this curve. Here the limit of y will be y square equal to 2x, so y will be root of 2x, plus minus hai, but since you are dealing in first quadrant, so root 2x, this will be your limit. Secondly, x varies from this point to this point, that is x varies from 0 to 1. These are the limit for OAB. For ABC now, y varies from this curve to this curve. This curve is y is equal to x, so y varies from x, y is equal to x to this curve, and this curve is just now found plus root 2x, so y varies from root 2x. At the same time x will vary from 1 to 2, and therefore the answer will be OAB, x is equal to 0 to x is equal to 1, y is equal to root 2x minus x square to root 2x of, question is xy, these are the limit of y, so dy first and then dx, plus integration, again x is equal to 1 to x is equal to 2 constants, then y is equal to x to y is equal to root 2x into xy, limit of y, so dy first and then dx, right? Now your question reduces to solving these two integrations only. So let us solve them. 0 to 1 as it is, you are integrating with respect to y, so x is a constant. What is integration of y? Y square by 2 from root 2x minus x square to root 2x into dx, plus integration 1 to 2, x as it is, you are integrating with respect to y, and therefore this will be y square by 2 from x to root 2x into dx, right? Simplifying this, next step, 1 upon 2 you can take outside here also, so 1 upon 2 as it is, 0 to 1 as it is, x as it is, integration y square upper limit is 2x, root 2x square is 2x only. If you want you can write root 2x whole square minus root 2x minus x square whole square, right, into dx, plus integration, again 1 upon 2 taken outside, 1 to 2, then x as it is, again root 2x whole square minus x whole square. Simplify this, this is 1 upon 2 as it is, 0 to 1 as it is, x as it is. Simplify this, this is 2x minus x square into dx, plus 1 upon 2 integration 1 to 2 x into root 2x is 2x minus x square, is it right, into dx. Continuing on next page. Ten. Continuing on next page, this will be I is equal to 1/2. You can take out 1/2 common from both these equations if you want. So inside this is 0 to 1, x into 2x get cancelled, right? So only minus x square. I'm sorry, you have to take this bracket. So minus of 2x get cancelled and minus plus x square. X square into x is x cube into dx plus here it is 1 to 2 2x square minus x cube into dx. Now simplify this. This will be 1/2 as it is, integration x raised to 4/4 from 0 to 1 plus 2 as it is, x cube by 3 minus x raised to 4/4 from 1 to 2. Put the upper limit, lower limit, simplify this. 1/2 as it is. This is 1 minus 0. 1 minus 0/4 plus 2/3 as it is. This is 2 cube minus 1 cube minus 1/4 as it is. 2 raised to 4 minus 1 raised to 4. Simplifying this, this is 1/2 as it is. This is 1/4 plus this is 2 cube is 8 minus 1 is 7. 7 2s are 14/3 minus sign 1/4 as it is. 2 4s are 16. 2 raised to 4 is 16 minus 1 is 15. 15/4. Is it right? Now simplifying this. Simplify this. This is 1/2 as it is. LCM is 12. So this will be 12. So 3. Here you need 4 multiplication. So 14 4s are 56 minus 15 3s are 45 divided by 12. Let us simplify this. 1/2 as it is. This is what? 59 minus 45, that will be 4 14. So this will be 14/12. So the answer will be 7/12. 7/12 will be the answer for this whole region, right? This was asked in 2013 examination. I hope you understood. All right.